Next example is to count the numbers of the lowercase and the uppercase letter. The function has two output, nums up and then num low, like this. Okay, we can use the similar text summing up each logical vector. In this case, uppercase and lowercase. We can summing up this logical vector, right? And assign this here, assign here, right? And then, for instance, in this case, you can plug in this one. This will give you the numbers of the uppercase, numbers of the lowercase. That's simple, right? Okay. Now we can design the function to perform this operation in a different way. In the previous case, we are designing the two output variable, numbers of the lowercase and numbers of the uppercase. But what if we can make the second argument to let user to choose the lowercase, the uppercase? Do you remember sort function? We can sort the vector in ascending order or the descending order using the second character vector called the ascend or the descend, right? Similarly, we can make the same argument to give it an option to the user, okay? But in this case, LT case is the variable that accepted this two option. One is upper, the other one is the lower. So how to design this function? That's simple. So same script, but you can design this selection statement. Okay, if LT case is offer is equal, this text is the same with offer, you need to do this, run this script, which is the counting the numbers of the uppercase. But if the LT case is lower, we can count the numbers of the lowercase alphabet. Okay, and also we need to design this else, which means sometimes the user is to put the wrong second argument. Then you need to print out this message, wrong second argument over LT case, and then stop the executions of your code. Okay? Can you understand this logic? We already learned all this syntax. We just have to practice how to arrange them to perform our specific task. Okay. So let's do the MATLAB demo. Okay. Okay. So here, let's copy this. Okay. Okay, this is the function of the checker character case. The story is near the folder, and then let's say character var is the STEADB, like this. Oh, sorry, this one should be like this, and then execute check character case character vector. Option is the upper. The output is the numbers of the uppercase letter, that this one BD, right? How about the lowercase? Lowercase is the 4 ASD and A, right? What about we are using the wrong character like this, and then this MATLAB produces the error message error using this function, then print out this message. Make sense? Okay. You can use the case, switch case. Okay. Switch LT case. How to design this? Case upper, right? Then case lower, like this, and then this one otherwise. Okay. you can design the script like this. Okay? It's basically the same operation. Okay, good. Okay, so I'm going to talk about the concept of the local function. The multiple functions can be written in the same file. The function of each name is the same as the file name. Should be the place at the first. That is the main function. Okay, and then subsequent additional functions are called the local function. For example, in the my function here, and then let's say you're designing the program like this. So my function, and then this my function is called the my function sub 1, and my function is sub 2. However, if the function, this is sub 1 and sub functions are only used for the computing the output values of the my functions and will not be reused for other purposes, then you can store the subfunction 1 and subfunction 2 inside of the my function. You don't have to store the sub 1 and sub 2 function in each individual file. So think about if you're using the many sub function that are only computing the my function. If you don't store these are individual file, your folder is filled with the many the sub function, right? So if you use this syntax, you can only carry the one single file to compute this output value, and all this sub function is stored as a local function here. Make sense? Okay. In this case, it'll be more convenient and organized that sub functions are placed in this my functions all, because this one is exists only for my function, so we don't need to store them. Store this sub function as individual file, right? So here's the diagram. Okay, my function have a two sub function. Difference between the main function and the local function is that you cannot call the local functions from the other file. For instance, this is the my one function.m. This is the main function, and this is the local function. Okay, you can in the my function my two function is this one. There's just a function like this, but in this case, you cannot call this local function. You can call this a function, but you cannot call this function. Why? Let's think about it. Let's say you're storing this 3 function. Your file name is a my function all. When you in the other file, even in the script or other function, you can, if you call this function, MATLAB easily find where it is, right? Because you can reach this use this function using this file name, but MATLAB has no idea how to find this sub function, because these are the different, right? So in this case, the other file cannot access the local function, but there's a way to do that, but I'm not covering that method. So if you want to access this sub function like this, you need to store as a file, and my function is access this one. Then my two function can access this one as well, because the subfunction 1 is stored as an individual file. Okay, individual M file. This makes sense? Can you see the difference? Okay, now let's take a look at the bulls and cow problem. Okay, in previous problem, we stored this compute BC, compute bull, compute cow as a individual M file, right? For instance, here we designed this compute. We put this compute bull in the individual M file, but in here compute bool and compute cow are only used for compute the variable in the compute BC, right? So you don't need to store this compute bools and compute cow as an individual M file. So you can place this one as a local function. Okay, place at the end of the main function. Okay, so this should be the compute BC because the M file should be follow the main function names of the main function. Okay, so in this case, if you run this, you can get the same output. Okay? But in this case, you don't have to store individual function using the 3M file. M file goes to 1 M file. That's very convenient, right? So we can also contain the function in the script. Okay, so in previous example, function is the store at the individual M file. So if you store in the M file, you can see that this is the script icon, this is a function icon. But you can contain the function in the script. Okay, that is something that is talk about this slide. Okay, I have used the MATLAB for almost 10 years. When I learned the MATLAB, this syntax was not available. Okay, when you test your function, you need to have a separate M file, so like a strip file. Okay, for instance here, okay, let's say I want to test the compute BC. To do so, we need to, this is a command window. We need to make the true sequence and test the sequence and then test this compute BC. But you know, in this case, this is very inconvenient, right? For debugging. If there's a problem, you need to open up this one and then, you know, putting in this file again, or this one. To debugging this file, you need to, you know, let's say str then 1 2 3 6. I mean, I did the previous example. Okay, 5 4, right? And then so here this one. Okay, the point is to run the compute BC, you need to have this script file, right? Or you can directly putting in this command window. Okay, do you see my point? Okay, however, since the 2016, you can include the functions in the script. That's extremely convenient for testing purposes. Since the functions are as a part of the script, all functions are considered as a local function, which means you cannot call this a function from the outside of from the other file. Okay, but this is good for the debugging. Okay, for instance, here in this case, you can you can put the compute BC, compute cow. I mean, we already saw this. This is the compute cow and then compute bool, like this. Okay, all this the compute bool, compute cow, compute BC is all the local function. Okay, so if you run it, see this is working. What it means is you can change the testing sequence here. Check the function that you design. That's the very useful features that the MATLAB supported since 2016. Okay, basically you will get this kind of the script. Okay, you can change here. This kind of the script, you can change this true sequence and test the sequence and run it, and then check the bulls and cow here. Okay, with the 1 single script file. Okay, script and file. But remember that all these local function they should be placed after the script. Okay, that's very important. You already see this local function in the tutorial problem. If you see the word puzzle problem, I create the function to generate the word puzzle. That's the local function. Okay. Okay, now you're changing this is true and then test the value and then testing the compute PC. For example, you're just check if the bulls and cows are correct. Okay, and then you think that compute PC producing the right outcome. Then you're storing the compute PC and then other sub function compute bull and compute cow as a single M file. Then that become a the custom function. You can access this custom function from the other file, select a built-in function. Okay, that's the process. Okay, in this structure, the adding the script on the function that helps to debugging the function that you're going to design, right? Variable scope is the workspace in which is the valid. Okay, script use the script use the base workspace and then store the value in the base workspace. Okay, however, each function, a local function or the function defined is a place in the other file, does not use the base workspace, and every function has its own the function workspace. Okay, base workspace and the function workspace are separate space. They are not shared any variable. That's the important. Okay, so the scope of the variable is limited in each workspace. In the script, when you call the function, you send the input value to the function, right? So what it means is the function only accesses that value, and then they cannot access the other value in the script. Okay, what is the benefit of this one? Okay, so let me show this example. Let's find out the bulls and cow. Okay, this is a true sequence, this is a test sequence. Okay, let's do not use I'll say the function that we design. So this is the bull plus cow, and then this one is so numbers of the bull. So okay, bulls become a num-bull, cow is the num-c minus num-b. Okay, so let's comment it out the rest of the script. Okay, and let's run it. Okay, let's see the workspace. Okay, so here's i's and it's the same, and num-b and the num-c is not necessary here, right? So what it means is that this is a very simple script. So only the extra 4 variables are produced in this script. But if your code is getting more complex, your script is producing lots of like a variable, okay, and then store in the workspace. This is not efficient because this is kind of the variable stored in the memory space. If you store the many variable in the memory space, this computation process is getting slow. Okay, so we can to avoid this this issue, we can just clear if else, for instance, when shoe finish to use the variable, we can use this clear val, or we can use the function. Okay, let's see this one. Okay, in here, okay. Okay, now if you run this, okay, sorry, compute bool, compute cow. Okay, let's do this. Okay, this is original code, right? And then if you run it, see, because once you finish computing the output from this function, all other variables except for output variables are deleted. That's why in your workspace there's no variable. So the point is the workspace are not shared between the script and the function, and then once you know the function is the returned output, all the variables used inside the functions are deleted. Okay, so I'll show this example, and then you'll see what it means. Okay, so this is the script from the previous slide. Okay, let's make a breakpoint in here, and then let's run it. Okay, let's see this example. I put the breakpoint and then capture the workspace. This is a workspace window in MATLAB. Okay, and then let's see what kind of the variable inside of the place in the workspace. Okay, when this script is executed, where does the code stop first? Here? No, right? Why? In this case, run it. In this case, call the compute BC, right? So this case, go to here, and then run the compute bool, right? And then this code goes to here. Compute bool is the same, and then stop here first. It's the line 16. That is this one. Okay, stop at the line 16 first. Okay, let's see what kind of variable in here. Okay. XTR and XTS is this is all used in this compute bools, right? And then this is returned. Num b is returned to here, and then stopped at 10, right? Then let's see the variable here. There's no this variable here, right? Bool is already computed. This the value is already returned from the compute after executing the compute bools, right? Bool is the 2, and then this one is this input value, right? So, and then line 10, and then this one goes to here, stop at line 25, right? And then there is the II variable and num_c, right? This kind of the variable here, because each function has on the workspace. Okay, you see my point? And then run this at 25, and then this goes to here again, and then stop at the line 16. So this one first, second, third, fourth, fifth, sixth. Okay, and then compute bool again, and then you can compute the num_c, and then goes to here. Then finally this code, go to here, stop at 11. You can see that bulls and cows are already computed, and this will be returned to here. Okay, that's why finally stop at the line 6. You'll get this value. Okay, do you understand this process? And then you need to, watch how the variable scope or the workspace are changing, in each stop point. Okay? In some, again, the function has own variable scope, and they are not shared with other function. They're only existing while this function is executed. Okay? Okay, this is a wrap-up example to check what we learned in this module, which code executed without error. First, we call the my function mean here. Okay, and then send this input vector here. That is a vector, and then an element. Where's an element here? That is in here. That's why error. Why? We cannot, this an element is not shared with the workspace in the function. That's why you cannot access this value inside of the function. Make sense? Okay. The second one, back, you can send the back here and send back. In this case, an element is computed using the back input argument, input variable, and then you can compute the mean value. So no error. Okay, what is the problem of this script? That is, mf mean is called back, right? An element is computed, but in this case, mean is accepted two input argument, but in this case we can provide one input. That's why there is error. Okay, what about this one? It's a working code. Since we cannot access an element, we need to compute that. That's similar to this one. Okay. That's why we recompute an element, or if you don't want to compute this part, you can like an element. Okay, you can send this variable is a value to this my function mean as well, so that you're not computing this value. Okay, that's it. So we will do the many practice on designing the function in the rest of the course. Basically, all the script that you designed the previous model can be turned into the function. Okay. Hopefully, you can clearly understand why we use the function and how to define the function through this lecture. See you next lecture. Bye.